Hey guys, how's it going? Thanks for tuning in. Today we're going to be talking about inverters, and specifically, as you probably already guessed from the title of the video, problems we have with them. I'll cut to the chase right away and show you what my system is doing now. After about 2 weeks of use, we go to our inverter, no load applied, turn it on. Yeah, that's a happy sound, isn't it? Turn it off, give it a couple second cool down, try it again, and we get the same issue. Unfortunately, it is definitely dead in the water. So, next question we have to ask ourselves, obviously, is what caused it to die. It's been, the voltages applied across it have been at a healthy load the whole time. They've been applied through overgauge wiring, so I don't think under voltage feeding it was the issue. The temperature in the back, although it doesn't run at 129, it really only gets that hot in the car on the weekends when I park it and like the windows are rolled up and it's just the batteries in here are recharging. But 129 is still very high. That's our most likely culprit. But I'll see if I can insert a screenshot here. This inverter is actually spec'd to run shockingly up to 158 degrees is the specs they list on their website. I'll see if I can show that clip here. So it didn't get anywhere near its maximum the maximum heat that it's spec'd to run at. The voltage applied was good. It had a good capacity to draw from. What else could it have been? Actually, when I first got this inverter, it's acted a little funny since day one. So I think maybe there's a chance that I got one that just had a few little defects on the inside. I've talked to Renogy 3 or 4 times about some of the quirks that it has. And obviously the first thing he said was like, well, the application you're using it for is pretty unorthodox. You know, normally ours are just used to run like refrigerators or air conditioners, normal household appliances, things like that. They said nobody's ever really tried to use one of these things to run a car charger before, which I get. But I mean, it's just a normal 1400 watt load. The inverter's spec'd for 3000, so that shouldn't have been a problem either. About 2 weeks ago, I actually went online and I was shopping around for an alternative because this one was acting a little quirky. And I was looking for ones that had good reviews that a lot of people liked, and I found the Energizer 4000 watt. So I ordered that, got it in the mail from Amazon, installed it, and it actually didn't work right out of the box, which was another piece of bad luck and pretty surprising to me. I went back and looked at all reviews, and I knew when I ordered it that there was about 5% of their reviews that had basically zero functionality right out of the box, and I guess I was one of those unlucky 5%. I went online and posted my review just to do my due diligence and let other people know the problems that I had, and the company got back to me and said, the manufacturer, that, you know, maybe it was installed wrong or whatever, and that was a little irritating because with, you know, this isn't the only negative review on there. They have to know other people have had this issue. But anyways, the good news is, because of Amazon's return policy, I was able to get refunded for the non-functioning Energizer inverter. Renogy didn't give me any kind of pushback on sending this one in for a warranted refund, so it looks like we'll be good there. In spite of that one product having some issues, I still, I guess, stand by my endorsement for whatever that's worth of them. All their other products have worked great. I love the charge controller. That thing is awesome. The way it stores data so you can go back and look at how much power you got from solar each day is really handy and kind of unexpected for something that cheap. So now that brings us to inverter attempt number 3. I went online and looked at what some other off-gridders use. People who lean on these things like this. The inverter is what supplies the power for their home. They don't get it from the grid. And I figured this is going to be the place to look if you want to find something that you can rely on. And this was what it seems like most of them, the brand that most of them were using. This is our Reliable Electric brand 3500 watt pure sine wave inverter. One of the features it has right up front that I really like is it's got these digital readouts on there. They're going to tell us the voltage of the batteries at a glance, so we don't have to use the multimeter on those. I don't like how close the outlets are together. That's going to be something I'll have to work around. And it's about 2 inches longer, so it's going to fit a little tighter in the back. But none of the features or dimensions mean anything if it doesn't work. One of the good things about this channel is it gives me a chance to filter through products that aren't going to work for this job, because I don't want if anybody goes behind me and does this, I don't want them to beat their heads against the wall, rotating through the same list of all the different products that are out there, trying to find something that's really solid for this application. If I can do this video and put it out there and make it a lot easier for everybody else, that's kind of my objective here. And I'm not going to paint this as some kind of rainbow and butterflies project where everything works right up front and it's easy and you just toss it on there and there's no problems at all. That's not the way that developing new applications for technology like this works. You have to rotate through the tools that are available to you until you find ones that will really work good together and give you the results that you need. I believe that there is a combination of different panels and charge controllers and batteries that is out there right now that we can get that'll be cost effective, that'll get this system running very hassle-free. I believe that's out there. But if it's not, I'm not going to conceal that from the viewers of this channel. I'm not too proud to admit that, that my harebrained scheme didn't pan out. I take more pride really from saying that I had the guts to try it in the first place than from not being able to admit that it didn't go exactly the way I want. So we're going to get this thing hooked up, but there is one thing I noticed right up front. I'm reading the manual for it, and the ambient operating temperature range, it tops out at 104. This is designed for indoor use. So obviously, I mean, heck, it's 104 degrees right now, and I got the back door of this thing open and none of the electronics are running. So we're going to have to come up with some kind of micro AC unit. I've got this empty space still right in here. I think that'll be big enough to fit something in. That's going to be the next step. The pros of this will be, the pros of applying a climate control to a system like this are that it's going to make life on all your electronic components a lot easier. It's going to make them last a lot longer. Electronics like to operate at about the same temperature we do, which is around 75 degrees. That's when everything lasts the longest. Additionally, it will, while you're going to have this top cover on here, so the unit's only going to be effectively cooling the maybe 5 or 6 cubic feet of space that we have back here. A lot of that cold air is going to leak out into the cab. So when we get into our vehicle, it should keep the entire interior of the vehicle a little cooler, which is an awesome side effect. The downsides are it's going to add cost to the system, which I don't like. I always wanted this to be something super affordable right up front. And once we add one of these $600 micro AC units to the system, that's going to bring the total cost up to around $3,000, which I really didn't want to get near or go over. But as I'm looking at this thing, as the system's evolving, I'm not really seeing a way around that. So the AC will be next on the to-do list. Other good news is that most of these micro AC units only consume about 200 watts of power. So if your car charger's pulling 1400 watts and the climate control is only pulling 200, it means that only about 15% of the power that it's consuming when the inverter's on and running, only about 15% of the power is diverted to climate control. The other 85% still goes to charging the car, and that's a good trade-off if you're seeing increased longevity out of all the electronic components in the back, which is where all the expense is. The solar panels on top of the car, that represents less than a third of the cost of the system, maybe less than a quarter. All your expense is in the batteries, the inverter, and the charge controller. That's where all the cost of it is. So diverting 15% of the power to increase the lifespan of all those things is a good trade-off overall. But I'm going to go ahead and get the 3500 watt inverter thrown in there, wire it up, plug it in, make sure it works, do a little stress testing on it, and then I will have to go out and find a micro AC unit and wire it up back there and see how all those components work together. Okay, so it's all wired up. We've got our battery connections are really solid. You tighten those up a whole lot so you get real good connection on your positive and negative side. You don't want loose connection there, it can cause heat to build up. Our batteries are at 13.3 volts, and we turn it on. And the display does show 13 volts. That's not coming through real well on this camera. There we go, maybe you can see it now. And the output voltage is 121, which is pretty good. So why is this red light blinking? Well, I go and I look at the manual, and I see red light blinking, normal high input voltage reminder. Do not affect the usage. Alright, I think they mean does not affect the usage there. But that's really weird, because 13 volts is not a high, and now it's bouncing back and forth between 12.9 and 13. 13 volts is not at all a high voltage input for a 12 volt inverter. Car batteries, or these batteries when fully charged, go up to 13.6, so this is almost at the perfect operating voltage. This is where this thing should be the happiest, and we're still getting that blinking red light. So that's an issue right up there, right up front. The next issue was when we go to plug in our car charger, we get the blinking green light, which is indicative of the device detecting that it is not grounded. So I got a little 16 gauge grounding wire here, and I attached it to the yellow post on our exposed, and that should be our ground post, and I ran it right over here to the metal frame of the vehicle that we have exposed, and it was still not picking up a ground. It was still flashing. They do not include solid directions in the owner's manual on how to ground it, so I can't imagine any other way you would do it. I know my Renogy inverter had a little post that looked like this on the back of it that was labeled the ground, so I also tried wiring that little post right there to the frame of the vehicle, and I still couldn't get this device to detect a ground. So we've got an inverter that we cannot ground, that does not include real good directions on how to do so. Its red light is blinking, which they say is indicative of a high voltage input, but the voltage isn't high, it's well within normal range. So did we mess up the battery setup somehow? Is some way that we have the batteries wired throwing the thing off? And they've actually got a diagram inside this owner's manual of literally the exact setup that we have right here. So that's not it either. 4 batteries in parallel going to the 12 volt inverter. That's what we've got. We've done everything according to the manual. If you go back here, it says make sure the inverter switch is turned to off, connect the inverter to a fully charged battery bank, connect the electronic appliance to the AC socket of the outlet, and then turn the inverter on. So AC output is applied, Turn the inverter on. And we've still got that blinking red light, and our car charger still shows not grounded. I tried to run other appliances off of it too that detected ground. Things like a window unit, AC, I plugged in there through an extension cord, and the AC unit was also not detecting a ground, even once again when this yellow post was wired to the frame of the vehicle. So it doesn't look to me like this unit can be grounded. Also, I found other videos online of people who had wired this directly to the batteries and were not getting this red blinking light. So there's only one last thing I can think of. Maybe somehow these low voltage cutoff switches are in some way throwing this inverter off. It seems like a really long shot to me, but I'm gonna, just to be 100% sure, I'm gonna disconnect these and connect the positive wires directly to the batteries, and we'll see if that makes any difference. Okay, so we've removed the low battery shut-off switch from the equation by wiring this big old 40 gauge wire directly to the battery post back here. So you've got all 4 of your batteries in parallel. You've got a overgauge wire going from the negative terminal directly to the negative connect on the back of the inverter. Overgauge wire from your positive terminal to the back of the inverter. There's nothing in between the batteries and the inverter at this point. And we still get that beeping red light. So that's something that we can't work around. If that red light is connected in any way to this device not being grounded, even though I've tried to ground it in 2 different ways and been unsuccessful, but if that red light was in any way connected to the device not being grounded, that is not explained or covered at all in the owner's manual. So I'm trying not to think that I've gotten 3 inverters now. They're defective right out of the box. The Renogy one worked for a while. That one made a decent go of it. But the other 2, the Energizer and the Reliable Electronic inverters, seem to be defective almost right out of the box. I'm trying to find a way not to believe that, but I just don't see what else it could possibly be. Additionally, it's worth mentioning that while it won't run appliances that have a ground detect in them, if we plug in just a regular 2-prong appliance and turn it on, we do get power. That's kind of funny. That little blinking red light will change the speed that it blinks at when we turn on our appliance. So that's bizarre and a little unsettling. But the appliances that have a ground detect in them, like the car charger, and I mentioned I plugged in a window unit, will not work at all off this inverter. There's some kind of ground issue here, which you would have thought as a manufacturer they would have realized and put a little section in here on how to ground your inverter, but of course that is wholly absent. So that's where we're at. I'm going to ship this inverter back too, because there's several things that are, in my opinion, warning signs right up front about it. And if I'm getting any kind of questionable functionality out of it on day 1, I'm going to send it back. I'm not going to try and work around that for months and years to come. If you're an electrician and you're watching this and you see something obvious that I've done wrong here, please let me know. Reach out to me either at my email, lonestareaseyev@gmail.com, or in the comments section. If you're a inverter manufacturer and you want to showcase a great product, contact me also. I will plug your inverter on every episode I do from now on if you can get me something that'll work great for this application. I know this is a boring video. I don't expect a whole lot of people to watch a inverter functionality video. It's boring, but it is also important to, and I think, to document the pitfalls of the process along with the successes. I would much rather document the successes. This weekend I was planning on doing a video on custom making solar panels to go on little patches of the vehicle that traditional panels won't fit on. I was excited about that. I've started assembling some and I've got some good results from that. But then the inverter broke and I can't run the vehicle and use the panels until I can get the charge out of the backup batteries. So I had to stop and make this one instead. I expect this one to be up there in popularity with my other video that nobody watches, automatic battery voltage regulation. Also very boring, but like I said, I make these videos to communicate to people who are going to try and do this after me, the difficulties they may run into and things to look out for. And so the search for a reliable inverter continues. Wish me luck, and I will see you guys next time.